For question 72 through question 77, solve each quadratic equation for x. So let's pause right there and talk about quadratic equations. So quadratic equations happen when the highest power is 2 on any term. We had talked about the fact that if the highest power is 1, it's a linear equation. Highest power 2 makes it quadratic. Now this has a quadratic term, it has a linear term, and it has a constant term. Constant means that it does not change. It is a set number, right? Okay. Well, any quadratic equation can be solved using the quadratic formula. Quadratic formula is this guy right here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where the a is the number in front of x squared, your b is the number in front of the x, the linear term, and then the c here is your constant term, including the sign that goes with it. Anyway, while all of these quadratic equations could be solved with the quadratic formula, all but one of them can be solved by factoring, and applying the zero product property, which we talked about in question 71. Zero product property saying that if you have two numbers you multiply up to 0, at least one of those things has to be 0. So the goal here is to take a quadratic equation, factor it, these parentheses things, and then set each of those factors equal to 0, and that will tell you what your answers for x are supposed to be. Becoming adept at factoring is a skill that distinguishes an expert math student from a mediocre one, and it is a skill that you will use repeatedly throughout your mathematical career. So, in fact, we will use quadratic equations and solving those things by a variety of methods throughout the year. In honors geometry, you'll use it in Algebra 2, in pre-calculus, and my calculus students, of course, use it as well. Now, when you first learned to factor, it was probably pretty intimidating, it's confusing, it was hard to do, but the more that you do it, the better that you get at it for sure. So I'm going to start with a question like question 71. It is, or 72. It is the easiest kind of factoring to do, and it happens when your leading coefficient, the a value up here, is 1. When I say a, it usually is written like this: ax squared plus bx plus c is equal to 0. And when this a value is 1, like this understood 1, then it's the easiest of the factoring to do. Now, in order to understand factoring, what I'm going to do is FOIL. Factoring is basically foiling backwards. And let me show you what that looks like. Let's say, for example, that we had, in parentheses, x plus 5 times x minus 3, need an x in there, is equal to 0. Now, if you're going to solve this, it's pretty much almost done. All you'd have to do is that you'd have to set each one of these factors equal to 0 according to the zero product property, and then solve each of those very simple linear equations. Okay, but we're not going to make this equal to 0. Instead, what we're going to do is just take this as an expression and FOIL. Remember, FOIL is an acronym that means first, outside, inside, last, and it just helps you remember what order you're supposed to go in whenever you expand out this binomial times this binomial. Binomial just means a two-termed polynomial anyway. All right, let me get rid of those. Enter. And then take x times x. This is our first terms, and that's going to give us x squared. And then we will go x times negative 3, that's our outside, that's a negative 3x. And sorry, I'm going to run out of colors real quick. 5 times x, that's our inside terms, that's 5x. And then finally, I got this light blue here, 5 times negative 3, that's our last, and that'll be a negative 15. All right. Easy. Now, of course, what we would do is that we would combine up these two middle terms here, because they're like terms, they're linear terms. You just combine the two coefficients here. In this case, a negative 3 and a positive 5 is going to give me a positive 2. So then I bring down my whole entire simplified quadratic expression as x squared plus 2x and then minus 15. Okay, so That was foiling. Going backwards from foiling is called factoring. And it's a tough skill, but it is a skill that is worth mastering for sure. Okay. But understanding factoring, it just comes from an understanding of what happened whenever we FOILed our binomials here. Okay, I'm going to work this process backwards. I'm going to first look at the fact that we have inside of the parentheses. Let me get rid of all of these little rainbows here. And let's look at the 5 and the -3. If I take the 5 and I multiply it times the -3, notice that I get my -15. And in fact, that's where it came from, right? It came from multiplying the last terms together. Whenever I multiplied these two together, I got a -15. Okay, so the first thing here is I would be looking for two things that multiply up to that last number, which is a -15. Right? It's going to multiply up to this -15. All right, but there's quite a few things that multiply up to -15, right? You would just take factors of 15, like 1 and 15, 3 and 5, and you just have to mix up the signs and stuff. In order to narrow it down, we're going to look at the middle term now. The middle term here is a positive 2x. We just want to focus on the 2, though, the positive 2. And notice where it came from. It came from combining up the -3x and the 5x. The -3 and the 5, those were also the same numbers that were inside of the parentheses because that's where it came from. It was the products of the outside terms plus the products of the inside terms. So if I just take those two numbers and I add them together, I'm going to get the middle term. So it's going to be two numbers that we're trying to add together to get the middle term of 2. And then again, the numbers that we found were 5 and -3, because 5 times -3 is -15. And then 5 plus -3 gives you, and oops. No, that was correct. That was correct. I was trying to put a negative sign on there, but it's not going to be because that's a positive 5. It's bigger. Okay, so let's pretend for a second that this is the quadratic equation that I have, and then I'm trying to solve it whenever this thing is equal to 0. So I'm going to go pretend like none of this happened and go x squared plus 2x minus 15 is equal to 0. Okay, so now I'm going to play this little factoring game, and this little factoring game is going to go like this. I'm looking for two numbers that when I multiply them together, I get the C value here, which is -15. Okay, and then I'm looking for those same exact two numbers that whenever I add them together, I'm going to get the middle term, the B term, which is a positive 2. Right there. Okay, so I go, what times what? And I would absolutely recommend you start with the factors, not with a sum. What times what is equal to -15? And they also add up to positive 2. So I know I'm going to use a 5 and a 3, and then I figure out my signs. Now, I would also suggest that you do that no matter how complicated this gets, and that is just find your factors and then you can start worrying about the sign. I know that the signs here are supposed to be different because it's a negative product, and I also know that the bigger number has to be positive because you have a sum which is positive. Okay, so that means that the 3 has to be negative and the 5 is positive. And I would take these same numbers and just double check it. 5 plus a -3 is supposed to be equal to 2. Okay, so far so good. We found our two factors because it's not like we ever knew what those things were supposed to be. Okay, so now what I'm going to do is this process right here backwards, and we sometimes call this expanding the middle term. The middle term was 2, and we're going to expand it into those two special factors that we just found. And then we're going to do some factoring by grouping. Okay, so instead of having the 2x right here in the middle, I'm going to rewrite 2x using the 5 and the negative 3, and it really doesn't matter which one of these comes first. However, if only one of your factors is negative, I would suggest writing the negative one down first. So I'm going to rewrite this as a negative 3x plus 5x, because if I were to add those two together, I would get the 2x in my original quadratic. Now just bring down the rest of it, x squared, and then minus 15 equals 0, right? And essentially, that's exactly what just happened here. Again, factoring is foiling backwards. Okay, so now what I'm going to do is I'm going to group up the first two terms, and then I'm going to group up the second two terms. If there was a minus sign in front of this 5, you want to separate that minus sign with a plus, so it would go like this, a negative 5x, put a little plus in front of it, so you don't chop off its negative sign, okay? Just a heads up. All right, get rid of that. Now that I've grouped up the first set and I've grouped up the second set, now I have two kind of mini factoring problems, and this is GCF, greatest common factor, GCF. Write it off to the side, GCF, greatest common factor. So I look at these two things and I try to find the greatest common factor between an x and a negative 3x. Well, the only thing they have in common is an x. So I'd pull it out. This is basically the distributive property. And I can do this one of two ways. I divide both of these terms by x and get the quotient left over, or I ask myself, hey, what do I have to multiply x by in order to get x squared minus 3x? Either one of those is going to give you x minus 3. You can double check this by just kind of distributing through this. X times x gives us x squared. X times negative 3 gives us a negative 3x. Okay, and then you did the same thing on the second one. But keep this in mind. If you do this correctly, this second thing that ends up over here has to also have an x minus 3 in it. And it will. As long as you do it right, it always will. 5x and minus 15. What's the greatest common factor? Well, 5 goes into both of these things. That's the biggest thing that goes into it, so I'm going to pull out a 5. And I don't want to just leave it like this with my parentheses. I want to bring the sign with it. I'm going to pull out a positive 5, so put a plus sign in front of that 5, and then x minus 3. Again, plus 5 times x gives us a 5x, plus 5 times negative 3 gives us a negative 15. Let's bring down the 0. All right. Then I have a new GCF. My new GCF is x minus 3. It's a little bit more complicated than the GCS that we were looking at before. However, it's common to both of these expressions, so it's the next thing that gets factored out. X minus 3. And then the second factor is, well, if I were to divide both of these terms by x minus 3, whatever is left behind goes in the next set of parentheses, which is x plus 5. X plus 5 is equal to 0. All right, before we finish this, I'm going to call your attention to this very, shortcut here so that you don't have to do this whole expanding the middle term every single time whenever your leading coefficient is 1. And that is the fact that the two numbers that ended up inside of the parentheses, the negative 3 was right there, and the positive 5 was right there. It's the same exact factors with the exact same signs. You don't have to do all of this stuff as long as you remember. You take those two terms, like these two numbers that we got, and we just plug them right into our parentheses. X minus the 3, and then x plus the 5. Now we can apply the zero product property, which states that if I have two numbers, two mystery numbers that multiply up to 0, at least one of them has to be 0. Could be both of them. So you go like this. X minus 3 equals 0, or x plus 5 is equal to 0. This first one, just add the 3 over, and you get x is equal to 3. And the second one, subtract the 5 over, and you get x is equal to negative 5. All right. One more thing about this, and that's the fact that, notice that after we were done here, This 3 and the negative 5 are the same numbers that we had before, but their signs are just opposites. These signs inside here are going to be opposites because you have to add or subtract those numbers to the other side of the equation in order to isolate x. So what this means is either one of these two numbers, when we plug it into the original quadratic equation, should make this thing equal to 0. So, for example, let's say I take this 3 and I go 3 squared plus 2 times 3 minus 15, that should be equal to 0. Double check it. 9 plus 6 minus 15, is that equal to 0? Yeah, because 9 plus 6 is 15. 15 minus 15 is equal to 0. It checks out. And then negative 5 should do the exact same thing. All right, so that whole entire process is what I would suggest that you do up here on number 72. Now, if you need it, I'll give you one more example. If you don't, just, give number 72 a try. But I'm going to go ahead and give you, from top to bottom, one more example for us to do together. And it goes like this. It's going to be x squared minus 9x plus 14 equals 0. Okay, so I'll play my little factoring game. I'm looking for two things that multiply up to positive 14. And those same two things, whenever I add them together, they're going to give me negative 9. Right, so this 14 came from the constant term, and the negative 9 comes from the middle term. So what times what gives me 14 and adds up to negative 9? And I'm thinking that it's going to be a 7 and a 2. Okay, that multiplies up to 14, but the signs don't work out. However, if they're both negative, negative times negative makes that a positive. And then if I add a negative 7 and a negative 2, I do get a negative 9. So those are my two magic numbers. Now, I know exactly what the shortcut is supposed to be, and that is to put these things straight into the parentheses. But just one more time, I'm going to go ahead and expand out the middle term. Expanding out the middle term is going to make this, instead of negative 9x, negative 7x, and then a minus 2x. Now, since I have two negatives here, what I'm actually going to do is I'm going to separate them with a plus sign. And that's just so that whenever I group stuff together, I don't accidentally chop off this negative sign here. So I just brought the other two things down. All right, I group the first two, group the second two. And now I do my GCF step, my greatest common factor. Between these two terms, the greatest common factor is just an x. They don't have any number in common, just the variable x, parentheses, divide both of these things by x. X squared divided by x is x. Negative 7x divided by x is negative 7. Okay, GCF between these two is a 2. However, the signs are going to be flipped because I need it to match up with this set of parentheses, which has a positive first term and a negative second term. So instead of just factoring out a 2, I'm going to pull out minus 2. Parentheses, and if I divide both of these things by minus 2, negative 2x divided by negative 2 gives me just x. And 14 divided by negative 2 is a negative 7. My new GCF is x minus 7, so it gets factored out. X minus 7. The second set of parentheses is the thing that's left behind, which is x minus 2. And once again, we could have gone straight to our set of parentheses, sets of parentheses here, because shortcut when leading coefficients 1 is just take these two numbers, put them into the parentheses as x minus 7 and x minus 2, so like you see there. And then it's not quite finished. Zero product property says that maybe x minus 7 is equal to 0, which means x is equal to 7, or maybe x minus 2 equals 0. In that case, x is equal to 2. So once again, that's the kind of thing that you're going to do on question 72. 73, however, needs a little bit more, another technique, which I'll show you in the next video.